Hi and welcome to this live demo of Polygonicus and Medial Ball Analysis. First thing to say is this graphical user interface is just a demo program. We don't sell it. It's not part of the product. The product is a software library provided as an SDK and embedded into other software, either for resale or sometimes used internally in factory automation. Okay, so I've loaded in a simple part, a simple mesh part, and it's got a variety of simple prismatic features. We could find these features using Polygonicus feature detection, so it would find things like these cylindrical holes there, the chamfers and the fillets, and islands and things like that. And it would give you useful parametric information like centers of cylinders, radii, radii of fillets and all that kind of stuff that you could then use for CNC auto-quoting, for example, or even for creating machining cycles. But we've added the medial ball analysis because quite often parts have freeform surfaces, and for freeform surfaces the feature detection is not quite so useful. It can't figure out the parameters of a freeform surface. So instead what we're offering here is this medial ball analysis. Now what medial ball has done is it's sampled across the surface in all the different directions, etc. And for each sample point it's computed the radius of the largest sphere that can fit at that point. Here it's picked a let's say 4.1, so let's just change that to 5. And what we're doing here then is we're saying that anything in dark blue you can fit a sphere of diameter 5, and anything in any other color you can't. And the color map goes from dark blue through green through red. So red is the sort of tightest curvature or smallest sphere that can be fitted. Now Polygonicus has computed all across the surface already, so we can just change this color map dynamically. So all I'm doing here is just changing the threshold at which changing the threshold at which things are colored dark blue. So okay, let's pick something like 25, and at 25 you can see these areas are dark blue, but for example you can't machine the top of that, or you can't put spheres onto the top of that. Because this other wall is getting in the way, and then there's no fillet there. It's just a sharp edge, but you basically can't get a large sphere into that point. Okay, so that's useful for auto-quoting, and it's also useful as a kind of idea of, well, what is the curvature of this part? So if you're a CNC machinist and you're going, well, I've got this part, what tools am I going to use to machine it? Then this can very quickly give you an idea of where those tools can get to. Now it's worth saying that this isn't a full accessibility check. I mean, a tool is on the end of a shank, which is on the end of a holder, and the holder is much bigger than the tool. We're not doing a full clash analysis to say that a tool holder can get into an area. All we're doing is looking at curvature and local clashing, if you like, which can give you an idea of where a cutting tool can reach. Okay, and if I click some points on the surface, for example, here. It's telling us 42, so you could fit a 42 millimeter ball there, and similarly here you could fit a 45 millimeter ball. If I go nearer that wall, I can fit a 12 meter ball. Nearer this island, I can fit a 20 millimeter ball here. That's partly because the island's lower, so here you've got a large wall, whereas here you've got a low island, so the sphere would go up kind of like that. The other thing I'll say also is that the algorithm has callbacks, so it works based on a faceted mesh, but it has callbacks that allow you to feed in information from the CAD BREP surfaces if you've got them. So that can help increase accuracy. So in effect the algorithm will say, well, can you tell me information about the CAD surface in this area? So for example, tell me the exact point on the CAD surface and the normals, etc. And then it will use that as part of its medial ball calculation to give a more accurate result than you can get from the faceted model. Having said that, what we found is in most cases, the faceted model is pretty good. The medial ball will adjust based on the local curvature of the facets, and actually it gives a pretty good result, and we don't see wild differences between a medial ball result calculated just from the facets versus a medial ball result calculated from the CAD part. Okay, so I'm just going to show a couple of other models now. This handle mold, I mean, this is kind of what it's meant for. Here you can see there's very little in the way of prismatic surfaces. These cylinders here are possibly cylinders. I haven't tried fitting those with Polygonicus surface detection. But let's just compute the medial ball, and you can see, so it's picked a radius of 2.1 just for the display. I'm just going to change that to 2, and you can see it's found the small areas where you could only fit a small cutter, or where you would need a small cutter to get into. But also there's a gap here which is interesting, so let's look at that. And if we look at it from the side, then yeah, you can see that there's actually a small step, so you'd need to take account of that when you're machining. So let's increase this now to say 10. So now with a 10mm cutter, again, you can get into a lot of this cavity, but you can't get into this area around here. You'd need something smaller to get in there, and similarly, you'd have some problems at the end there. And then if I increase it again, let's go 25, for example, then yeah, we've got that's a pretty big cutter, but you can still reach the top of this island. But if we double click here, you can't reach this bit because actually you'd need something around 12 to get into there. So it's a very, very quick way of visualizing the curvature of the part and the types of tool radiuses you might need. And again, along here you can see this wavy pattern. That's because we've got these islands protruding up. So if I click here in between the islands, I'm going to be able to fit a bigger sphere, 15, than I can at an equivalent point here where it's 10. So again, it's taking into account this local accessibility. Okay, and I'll just try one more large part. So this one's pretty big. It's going to take a bit of time to compute, so I'll just get that going. So you can see it's quite a large area, 600 by 375 by 250, so it's a pretty large mold. It's not that heavy in terms of number of polygons, 685,000, but it's got a lot of detail in it. So if you wanted to sort of find out where you can or what you're going to need to machine this, then you have to be quite careful when you're looking around. But the medial ball is going to tell you very quickly, and it's, as you can see, it's done all over the part. There's a lot of information here. So it's picked a, let's say 6, let's just make that 5 for the sake of argument. Say we've got a 5mm cutter here, and understandably there's no problems machining these freeform surfaces here, and you can get into there with a 5mm cutter even. If I double click on it, it's telling me 8 mils. So let's just say, let's say we had a 10mm cutter, and then you can see, yeah, we can't get into that bit. We need, with 10 mils. And let's go back down. I'm just going to go down to 2 and look at these red regions. So again, with unsurprisingly, with a 2mm cutter, you can machine most of it. But there's these channels at the bottom, and if we look at them, you can see that they're sloped. Maybe they're pointing directly upwards, a bit hard, but the walls are not. The walls are diverging slightly. So what we're not saying is you can necessarily access a tool in there, but what we are saying is that if you were to get your tool into that, it would need to be much smaller than 2 millimeters. And in fact, let me go down to say something like a half. Now, if I go to a half, we can get in there. But if I can go to 1, then we can't really, or it's certainly not clear cut. So you need to have a pretty thin tool to machine those if that's how you're going to create them. Let's just zoom out, and then I'll go the other way just for the sake of it. So let's say 50, and you can see still all of these freeform surfaces are largely reachable, but as you'd expect, most of the complex detail isn't. And then I'll just go bigger still, so something like 150, and then okay, a tool with a 150 radius would be a big tool, but you can see we can't get into most of the part now. Okay, so that's a quick overview of medial ball analysis. Thanks very much for listening. If you want to contact us, you can contact us via the website, and we'd be happy to chat and tell you more. And if you want to evaluate Polygonica, it is available for evaluation, so please do get in touch. Thanks for your time.